Now, here's our tool for computing the area bounded by the polar graph sum equation. However, if I want to look at the area bounded in between the graphs of two polar equations, then what I'm going to do is take an integral like this, talk about the outer radius, subtract from it the same integral, but using the inner radius. Now, rewriting those as a single integral. Doesn't that tell me the graph? Sorry, not the graph. Doesn't that tell me the area bounded by two polar graphs can be computed by evaluating this integral? Outer radius squared minus inner radius squared, and we're integrating with respect to that parameter, theta. So if I have a lemniscate, a circle, we know what they look like. X-axis, Y-axis. Here's my lemniscate. I don't know how you graph this. You might be sketching this from looking at specific points, maybe looking at over intervals. I can't use my technique of sketching the particular graph first in the sense that it's not a nice, clean sinusoidal wave. I personally would look at intervals, 0 to pi quarters, then to pi halves, then to pi. Sorry, 0 to pi quarters, then to pi halves, then to 3 pi quarters, then to pi. Now there's my lemniscate. My circle looks like this. I want to find the area bounded by the graphs of these two. I don't know if I worded that very well. How about if I change my words? Looks like the area within the graph of this lemniscate, but outside the graph of that circle. And we're talking polar-wise. And so I'm looking at the area here and here. I'm tired, I'm lazy, I don't want to do all that work, so if you don't mind, I'll cheat and simply compute this area and multiply the result by 4. Now to do that, I need to find the value theta that gives me point of intersection here in the first quadrant between the polar graphs of those two equations. So to find that value for theta, let's go ahead and take the r values, take that back. Let's take the r squared values on one, the r squared values in the other, and equate them. Does that give me the theta is 1/2 inverse cosine of this? Sorry, can I stop for a minute and double check my arithmetic? Looks good. So the area should be computed by looking at 1/2 times some interval, but I'm actually going to quadruple the result. And we're integrating from 0 to, would you mind if I don't write the angle up there? It's just too long. And so can I just call that theta sub 1? I'll put it in when we need it at the end. Now the outer radius squared is given by this expression. The inner radius squared is given by this number. We're looking at a difference in integrating with respect to that parameter theta. Sorry, I'm stalling. I'm tired. What's the sign of the inverse cosine of 4/9? 81 minus 16 is 65. I hope over length hypotenuse. Or how about better yet, this. Barring any arithmetic errors, that is exact area on the outside of the circle, but inside the lemniscate, I've only got shaded in 1/4 of it, but this computes all 4 portions here, 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 and here. One tool left, our